Hi everyone. So just following on from yesterday's video where I discussed Gibbs free energy and how we can essentially calculate it by changes in entropy and enthalpy, today I want to discuss how we can actually predict changes in entropy and enthalpy. So just as a quick refresher, enthalpy is essentially how much heat is in a system. And the mnemonic that I like to use to remember this is that the TH within enthalpy reminds me of a thermometer. And with thermometers, we measure body temperature, or rather the heat of the body. So that's how I remember that enthalpy is heat. Alternatively, entropy is, we just use this term to describe how much disorder or how much chaos is it within a system. And there's a number of ways we can actually predict changes in entropy itself. The first one being temperature. So just think about a balloon, and when we blow a balloon up and we start to heat the air molecules inside, we see that that balloon starts to expand. And one of the big reasons why this happens is because the individual air molecules within that balloon start to gain more energy. And they start to, act a little bit more sporadically. They bump into each other, they bump into the balloon, and they just go a little bit more random and chaotic, I guess. And that's one of the reasons why this balloon expands. So with increases in temperature, we get an increase in chaos or entropy. One of the other things is the phase state of the matter itself. For example, when we go from ice to water to steam, we see that entropy increases. When we look at the individual water molecules within ice, they're quite ordered and very structured. However, when they start to go between ice to water and water to steam, these individual H2O molecules become a little bit more disordered. They're not as aligned as they are with ice. So as we start to go from a solid liquid to a gas, we see that entropy starts to increase. So the last thing we can use to determine changes in entropy is looking at the changes in the actual number of molecules that are happening in the reaction. So take, for example, the dissociation of water. This is just for an example. With the dissociation of water, we go from 1 mole of H2O into 1 mole of hydroxide, which is OH, as well as 1 mole of hydrogen ion. So essentially in this reaction, or in this dissociation, we're going from 1 mole of a compound, which is water, into 2 moles. So 1 mole of hydroxide and 1 mole of hydrogen. In this, we're essentially increasing or doubling the number of molecules within that system. And because of this, we're increasing the disorder or the chaos within that system itself, and therefore the entropy. So it's just important to remember, if we start to increase the number of molecules, we're starting to increase entropy. So compared to predicting changes in entropy, it's actually much easier to predict changes in enthalpy. Because enthalpy is essentially how much heat is in a system, if we increase the temperature of that system, we're increasing the enthalpy. So when predicting changes in enthalpy, any changes in heat will also change enthalpy. And again, increasing the temperature will increase enthalpy of that system. One of the other ways that we can also predict enthalpy is looking at whether there's bond formation or bonds being broken. Now this actually correlates to Hess's law, but I'll cover that in a later video. But for now, all you need to know is that when bonds are destroyed, or when bonds are broken, it's a endothermic process, meaning that the enthalpy of that system is increasing. However, when we go back from these individual molecules and we put a bond to them, or we create a bond, this is an exothermic process, meaning energy is released, or enthalpy is being released. So the big take-home message is bonds broken, endothermic, enthalpy increases. Bonds formed, exothermic, enthalpy decreases. Entropy and enthalpy. And as always, if you have any further questions about the things that I've covered in this video, please feel free to comment below. If you found this video helpful in any way, shape, or form, it would be really appreciated if you guys could just drop a like below. It really helps the channel out. Alright guys, catch you in the next video.